This video is about scientific research, two types of scientific research, and general features of scientific research. One thing scientists clearly do a lot is research. This can include reading and writing scholarly works, experimentation, making and analyzing surveys, and more. The kind of research being done is sometimes defined either as basic or applied research. This distinguishes between the kind of research that is aimed only at generally improving knowledge about something, and the kind that strives to solve a particular problem, possibly leading to technological innovations along the way. The former is called basic or fundamental or pure research. Despite being mostly driven by general curiosity, it often ends up leading to many innovations once the significance of the findings has been understood. The discovery of electricity is an excellent example of that, or that of radio waves. Figuring out what to do with such discoveries would be applied research. Trying to invent a cure for a specific disease would also be applied research, but trying to understand how the brain works is basic research. The SETI or SETI at Home program is a project dedicated to searching for extraterrestrial intelligence. This has nothing to do with UFOs, unidentified flying objects, or UAPs, unidentified aerial phenomena, as they are now being called. Instead, it is real astronomy that you can participate in by allocating some of your computer's processing time on it. Go to the SETI at Home website for more information. The goal of the project is to see if there are signs of intelligent life anywhere outside of Earth in the universe. So far, no such luck. When I have asked my students whether SETI is basic or applied research, most have thought it's applied. It does seem to be about solving just one question, so that might seem right. But I think it's basic research, because it's only about trying to see what the universe is like. There is no obvious application for the discoveries SETI makes. It has found interesting phenomena though, so while no intelligent life has been discovered, it has increased our knowledge of the universe, which is exactly what basic research does. If you think differently, let me know in the comments below. In previous decades at least, people, even scientists, sometimes spoke of the scientific method, and in earlier centuries it was more commonly thought that there actually is such a thing. That is, one specific method which all natural scientists use. It doesn't seem to be quite true. Instead, scientists use many methods, and using one particular method in one's research is not enough to make it scientific. Instead, what could be called the scientific method is not just conducting one's own research in the correct manner, but also doing it as part of the scientific community, subjecting one's results to the critical examination of other scientists. That usually means presenting one's findings in an academic, peer-reviewed publication. Peer review means that some anonymous experts in the field check your work before it gets published. They suggest changes and improvements to the article, or recommend the editor to discard it altogether if it sucks. It's not because of the results you got, but because of how you got them. This method is a quality control to make sure that badly done work doesn't get published, especially in respectable publications. Unfortunately, there are also predatory journals that pretend to be proper scientific publications, but really are just making money, mostly from scientists who are just starting their careers and are desperate to publish, so they don't perish career-wise. These publications don't have real peer review, and they demand money from the author in exchange for the promise to publish. Stay away from them. But before you can publish anything, you need to do your research. Scientific research is generally thought to have certain features that distinguish it from other activities or ways of thinking. They include justifiability. The claims made or used in scientific research have to be properly justified. Testability. Scientific claims can be tested so that the results of the tests either support the claim or count against it. Repeatability. The aforementioned tests must be such that other researchers can repeat the tests, and they should get similar results. Objectivity or avoiding subjectivity. Scientific researchers strive for objectivity and impartiality. That means they do their best to avoid subjective biases, first of all by attempting to become aware of such biases, and then by designing their research so that it takes such things into account. That is one of the reasons why repeatability is important. If people with different biases reach the same results and conclusions, they are much more likely to be true. As I have mentioned earlier, this can also be called intersubjectivity, because even science cannot reach complete objectivity, but different subjects, scientists, can come to an agreement which is close enough. Conceptual accuracy and unambiguousness. The concepts used in scientific research cannot be ambiguous. They have to be clear, precise, and used consistently. Scientific research is either quantitative or qualitative. Quantitative means that instead of vagueness, accurate measurements and mathematical descriptions are used. Experiments typically require a quantitative approach. Qualitative means that instead of mathematical measurements, the goal is to understand phenomena and the intentions of people through interviews, hermeneutic study of texts, or other such means based on communication. Scientists have to compare and evaluate different theories, and so there are features that they look for. The following list is mostly based on Normand Baillargeon's Petit cours d'autodéfense intellectuelle, translated to Finnish by Tapani Kilpeläinen as Älyllisen itsepuolustuksen pikakurssi. Features of good scientific research include simplicity. When evaluating competing theories, scientists typically favor the one that posits the least amount of entities or elements. This is called Occam's razor, or the principle of parsimony. It is often stated just as the simplest explanation is usually right. But even though that is close to the point, it is not necessarily very accurate or true. Scope or breadth. Another aspect used to judge a theory is its scope of explanation. The more it explains, the better. Fruitfulness. A theory that can be used to make accurate and surprising predictions is interesting and certainly better than one that cannot be so used. Relative conservatism. A hypothesis or theory that coheres with the best knowledge we have at present is generally to be preferred over those that contradict our best current knowledge. In the next video I will be talking about scientific experiments. See you then.